This conference will now be recorded.
A very good morning, dear participants. So we are waiting for the other participants to join the session. So we will just wait for 2 to 3 minutes. Then we will start with this. And can you hear the voice? And anyone you can unmute and you can give a reply whether you can hear the voice. Your voice is low. Only
Hello. Yes, sir. Yes, sir. I can see, sir. Yes, sir.
very good morning to one and all present here. Um, Actually, we have this is the formal inauguration for the 1 week faculty development program which we have planned in our Institute Mallarity Engineering College on SAP-2000. And this program is scheduled for 5 days. So first of all, I would like to thank our management, our honorable chairman, the Honorable Garu, and I would like to thank our director, Ramswamy Reddy sir, for giving us permission to conduct this program. And I would like to thank Dr. Ravindra, who is the principal of our institute, for supporting us in all the activities what we have done. So this is a program which we have started for enhancing our skills on SAP 2000. Basically, you know what is the software. SAP 2000 is a software used for normally called a structural analysis package. We can do all sorts of 2D and 3D analysis and design, which is a most sophisticated graphical software. Normally, many may not be aware, or some may be aware about this particular software. So when we decided to start a program, we need a very good expert to conduct this program. So we are searching for a very good expert, and finally we came up with Mr. G. Arun Raj. Let me give a small introduction about Mr. Arun Raj and Mr. K. Tejaswini. So Arun Raj, he is presently working as the junior architect and the structural draftsman for URK planners and designers, and he has a wide knowledge on all software, nearly like SAP 2000, SAP Pro, Revit Architecture, AutoCAD, Primavera. Uh, he is the right person for us to train the as a resource person for this program. We have arranged him for this faculty development program. I think everyone will be very happy to attend this particular session. And we are very happy to have Mr. Arun Raj in our middle for being the resource person for this 5-day faculty development program. And we will be having Mrs. Tejaswini on some of the days. When Arun Raj sir is not there, she is going to conduct the program. And regarding this platform, go to meeting. Uh, every day the videos are getting recorded, and it will be sent to your mail ID. The link will be sent, and you can download the videos and keep it safe so that you can have a reference. You can work out. We have already sent you the software link. You can download the software. You can install it. Please try it once. And daily, whatever you start, please practice it, and please give us a reply on the next day, whether if you have any doubts or anything, please feel free to contact us. Contact Mr. Arun Raj or the coordinator, Ponchi or someone. You can put a mail if you are interested about your doubts. We are ready to clear it. And I request all the participants to attend all the sessions, all the 5 days, because the time is only limited, only 2 hours per day. So I request you to attend these 2 hour sessions and practice the things during your lecture time, maybe in the evening or something. Please do practice, because softwares, it can't be just like that taught and you can't be an expert. So practice makes a man perfect. So you have to practice again and again so that you can be well versed with software. So this is a very important software which can be used for your profession as well as for education. So you are M.Tech students, you can do your projects in SAP. So this is a very good platform where you can learn a new software. So I request all the participants to actively involve, and you can raise your doubts immediately if you have any. And as I told you, the videos will be sent to your mail ID. So please make use of it. And I hope all of you will be present on all the 5 days and make this FDP a useful one for both you as well as for the other. So I would like to thank the coordinators, Mr. D. VAMSI and Rakesh, for their efforts in organizing this particular program. Um, so without wasting much of the time, so we will proceed into the next session. Let me hand over it to the coordinator. So good morning, all the participants. I'm very happy that um, so participants are from different streams, like PG research scholars, and people are from industry also there in this FDP. And I request before we start the session, I request all the participants, so please mute yourself, and we will have 5 to 10 minutes, doubts clarification at the end of the session. And now I am going to transfer the screen and put organizer. Okay, so G. Arun Raj. I will make Arun Raj as an organizer now. So he's going to interact with you and he will start the session, right?
Hello.
Yeah, Arun Raj, now you are an organizer, so you can start the session.
Hello.
Yeah, Arun Raj.
Sir,
You
am
can
I
start the
audible and
session.
visible, sir?
Yeah, you are audible to me and you are the organizer now. You can start the session.
Okay.
You can share your screen and you can start the session.
Yes, sir. Okay. So, good morning, everyone. My name is G. Arun Raj, and I'm a structural engineer. Greetings from URK planners and designers. I have been working in the structural field from the past 4 years. The majority of the work which I do is academic and consultancy works. I'll give a short introduction about myself. I have completed my master's in structural engineering, and I have been into the structural field from the past 4 years. The majority of the work is the consultancy work which I do, which involves planning, designing, and delivering the project to the clients. This involves the elevation designs, interior designs, floor plans, and structural designs, and sometimes execution also. And coming to the academic project, the most of the project which I have done is taking up workshops for different batches, different students on different softwares, as sir has mentioned before. Hello.
I'm sorry, you can share your screen, Arun. Can you share your screen, Arun?
I'll be starting to share after sometime, sir. Like when I start to introduce the software, I'll be sharing the screen.
Okay, then fine. Okay.
Okay.
Right. Okay.
So as I'm telling, the academic things which I have taking part, or which I am taking up in the past 4 years, are majorly of the workshops. I will be taking the workshops such as STAT Pro, ETABS, SAP-2000, Primavera, 3ds Max, AutoCAD, Revit architecture. These are the softwares which I'm well versed in. These are the softwares which I used to take for faculty. I used to take workshop for the faculty, like this type of faculty development programs, and also I used to take up batches at different institutions, majorly like CAD Desk, ECL, CAD, and URK. The URK planners and designers also have a institution called what do you say, Tyrannical CAD, which is located in Gatkeser. I used to take up classes, and also I used to take up classes online from the past pandemic period. This is all about myself. These are the softwares which I'm well versed in. Now let us get into your 1 week faculty development program on SAP-2000. In this software program, what are the outcomes of the program are? By the end of this program, you'll be learning how to model a structure, like how to model a framed structure which has beams, columns, and slabs, and different types of loading. How to model a structure, I'll be explaining you how to create different elements, how to create different materials, and how to how to make the project a real time, how to make a real-time project. And after that, we'll be going to the loading part. I'll be explaining different types of loading. The first one would be gravity loadings, which are generally dead loads and the live loads, and then we'll be going through the lateral loadings, the wind loads and earthquake loads. And after that, I'll be teaching you the analysis part, and then we'll be going to the concrete design, and then we'll be dealing with the steel design. And after that, we'll be completing all the general analysis part, whichever the things which are required for a civil engineer. Like this is the only the civil engineering part, the first part, uh, up to the civil engineering part. And the next one, after completing the concrete design part, we'll be having the higher analysis parts, such as whenever we talk about analysis, the analysis is classified into 4 parts. The 4 parts will be like static linear, which is general analysis, which we do for every model. And the second one will be your static nonlinear, which is your pushover analysis. And the third and fourth are dynamic linear and dynamic nonlinear, which are your response spectrum analysis and your time history analysis. Okay, guys. After that, after completing all these analysis types, we will be showing you our recent projects which we have done, like the concrete design, and I'll be showing you a real-time project. I'll be modeling a real-time project in front of you, and I'll be explaining how to add all the loads and all the things which we have learned in the whole FDB section. Okay. Coming to our FDB, let's start with the basic introduction to our structural engineering. So what are the different kinds of work which we do in our structural engineering? From the beginning, I'll be starting from our basic foundation stage. Like whenever we join in the BTech college, it is the first step of our civil engineering. The first thing, whenever we are constructing a project or whenever we're starting a project, the first thing which we do is surveying. Right, guys? I want you people, there is a chat box on the top right. If you are using the PC, there is a chat box on the top right. Just enter your message and send it. I'll be asking, let's be this section as an interactive section. I'll be asking few questions, and you guys can text your message. You can fill the message and you can put it in the chat box. Okay, you can respond using the chat box. The first one, whenever we have joined in the BTech, the first course which we are going to deal with is in the first year it is completely to the foundation part of our engineering. The main core parts come in the second year, right guys? In the second years, the first year, we will be learning about engineering drawing and engineering mechanics, which are related to our core part. Okay, and in the second year, what we will be learning is surveying. Okay, whenever we are talking about this surveying, we will be learning different kinds of surveying, right? So how this surveying is used in our construction field, like in the industry, in the field, how this thing is used is that whenever the client or the person who is giving us the project, he asks us to survey the plot first and get us the dimensions. So in order to get that, we need to have the knowledge about the surveying, right? Guys, I need you people to respond in the chat box. Hello. Okay, so this is the first one. First one is the surveying, and after that surveying, the next part will be our building materials. We will be learning about BMCP, building materials. What are the different materials which we use in our industry, and all those things we will be learning in the building materials. This will be very useful for the construction purpose. This is the second part. After the surveying, we'll be getting the plots. We'll be getting the plot area, the built-up area, and the dimensions. Based on this output which we get from our surveying, we will be doing this 2 types of plans. We will be doing 2 types of plans. The first one is your municipal permission plan, and the second one will be your working drawings. Right, guys? The first one will be your municipal permission plan, and the second one is the working drawings. The first one is the municipal permissions, which we use in order to submit for the municipality, and the second one is the working drawings, which we use to for the execution part. We will be using the working drawings. For both these parts, we require a submission 1 working drawings, right? For both these things, for both this working drawing and the submission drawing, we require a few knowledge from our BTech, from our academics. This knowledge will be incorporated from AutoCAD. AutoCAD is the basic software which we require in order to draw plans and elevations, right guys? AutoCAD is the basic. From all this knowledge of the working drawings and the municipal drawings, we'll be getting, we'll be only knowing how to draw the, how to use the tool, but the application of the tool, it requires few knowledge about GO 160, like 168, the government order 168. And also we need to follow some norms and regulations which the GHMs have given, like if there is a setbacks and the height of the building. If it is in a municipality, we have to follow a few setbacks, and also we need to follow a few rules and regulations for drawing these components. So this is all about our planning. And the next thing, what are the subjects in theory of structures which we learn in our BTech, in our graduation? What are the different subjects there? What are the different subjects which we learn in our theory of structures in our graduation? You guys can respond in the chat box. RCC, yes. Strength of materials, steel. Strength of materials, right? So there are few subjects in our there are a few subjects in our theory of structures which include the first one. The first one will be dealing with SM, right? Strength of material. The first subject will be our SM. We'll be dealing with SM in the second year, first semester, or second year, second semester. The SM subject will be for you. In this SM, what are the different topics which we will be dealing with in SM, strength of materials? What are the different subjects which you will be dealing with in SM? Stresses and strains. So in SM, the SFD, shear force diagram and bending moment diagrams. So basically in our SM, what we deal with is the material properties of any element. Like this is from the why I am explaining all these things right now is, whenever you use this SAP, you need to have the knowledge of all the materials, all the civil engineering, structural analysis and design knowledge. For this purpose, I am explaining all this in order to refresh you, and what we are going to do in this coming SAP program. So the first one is our SM. In the strength of material subject, the first one is in order to get to know the materials, the steel and the concrete material, the densities, their modulus of elasticity, Young's modulus, and their moment of inertia, the I value, and all these properties we will be learning in SM. And also our whole structural engineering or civil engineering, the analysis part is based upon only the foundation is based upon only one theory. The theory is nothing but a simple theory. It is called Hooke's law. Hooke's law. Do you guys remember Hooke's law? Hooke's law. Please respond in the chat box. If anyone knows the definition of the Hooke's law, just put it in the chat box and I'll tell you. The definition of Hooke's law is within the elasticity limit, stress experienced by a structure is directly proportional to the strain. Okay, so how this concept comes into our civil engineering is in our structural engineering is, whenever we do this analysis, the final outcome or the final result is that if the stress is exceeding the limit, or strain is exceeding the limit, or the deflection is exceeding the limit, we have to take care of all these properties. The basic is coming from the stress is directly proportional to the strain within the elasticity limit. So the basics, everything will be coming from the Hooke's law itself. Hooke's law. Stress is directly proportional to the strain within the elasticity limit. So this law is converted into few more advancement, and we will be using them in the structural engineering for the design and analysis part. This is from our SM. And the next part, after SM in our structural engineering, in our BTech graduation, BTech is after SM, we'll be having the subject called SA, which is called structural analysis. right guys? So what are the different in the SM we have learned regarding the materials, the properties of the section, and just only a single beam SFD shear force diagram and bending moment diagram. And coming to our SA, what do we learn in SA? Structural analysis. What do we learn in the structural analysis? Okay, I'll continue. So in the structural analysis, we will be dealing with different types of methods, such as our stiffness flexibility matrix method, direct stiffness method, Canis method, and lateral frame method, or portal methods. We'll be using different methods in order to find out the slope, deflection, and sway. Moment distribution method is exactly moment distribution method, portal frame method. We'll be using this type of analysis methods in order to find out the deflections, the complete deflections of a structure, and along with that, with the deflections, we will be finding out the SFD and BMD, shear force diagram and the bending moment diagram in structural analysis. Okay, we'll be only finding the deflections, moments, and shear forces which we get. Until now, in SA and SM, we'll be only finding out the results of shear force and bending moment. And the next thing after SA, we'll be having, until now we have dealt with the analysis subjects, and we will be entering into the design subjects, right guys? In the SA and SM, we'll be dealing with point loads, UDLs, and all this type of loads. Now we will be going to our design subjects. So what are the different design subjects which are available, which we study in our graduation, guys? What are the different design subjects? RCC, DSS, RCC. So when I was studying in my BTech, there were three subjects. The first one is your RCC, reinforced concrete structures, and the second one is steel design, and you will be having advanced structural designs, ASD. This ASD was an elective subject when I was studying. I took this ASD as my elective subject. Like this was like from 8 years back. I have taken this ASD, and in this subject, in the first one, in the RCC, we'll be dealing with three limit state method, working stress method in the beginning, and then we'll be going to design of beams, design of columns, design of slabs, design of staircases. So whatever the outputs, whatever the outputs you get from this SM and SA, you will be incorporating them into RCC or steel design, and you will be analyzing the structure. Like in the RCC, if I give a beam, of length of 5 meters, we will be doing the trial and error process, trial and error method, and then in this trial and error method, we will be fixing a dimensions. We will be fixing a dimensions of the beam and column, and then we'll be analyzing it for bending moments, like the formula mu is equal to 0.87 fy astd by fck bd. We'll be having this kind of formulas in order to calculate the ast, right guys? In the RCC, whatever the outputs we are doing is we'll be having the moments, we'll be calculating the moments, and we will be getting the outputs. The outputs are majorly our AST, and then we will be checking the structure for deflection or any shear failures or any type of failures. We will be checking the structure. This is the thing which we do in RCC, and then after RCC, what we do is after this AST, we'll be doing a last part in at the end of the RCC. Like if I give you a question, what is the how you represent the output of RCC, guys? How you represent the output from RCC? Like if I give you a problem to design a beam, if I give you a problem for designing a beam, after calculating all the ASTs and everything, how you represent the output of that problem? How you represent the result of that problem? Can I get some answers? Okay, so whenever you do this RCC problems or solving a beam, like finding out the AST. So exactly, distribution of reinforcement, and in this distribution of reinforcement or detailing, we'll be drawing a beam and we will be providing the reinforcement like the dots and the stirrups, and we will be saying #8 at the rate of 20 diameter, #9 at the rate of 16 diameter. Like we will be providing the details of the main reinforcement and the transverse reinforcement. This part again we are going to do in the AutoCAD. So basically first we'll be going to the surveying, then we will be getting the floor plans, and according to the floor plans we will be doing the center line diagrams, and from the center line diagrams we will be doing the model generation. We will be doing the model generation and we will be placing the beams and columns. We will be adding the loads and we will be analyzing our model, and then after analysis of our model we'll be doing this what do we call the different types of analysis. And after the analysis we'll be going to concrete design, and then after the concrete design we'll be doing this detailing part. So this is the basic fundamental thing which we learn in our civil engineering for designing any structure, right guys? So this is the basic fundamental thing. After this after completion of this course, like our graduation, a person should be able to, a civil engineering graduate should be able to do all this analysis and should be able to do all the detailing part. Like he should be doing this manually. Like after that whenever we are going to our structural engineering and post graduation, we'll be learning few subjects called few very important subjects. Like on the basis of these subjects we'll be doing the software part, like the SAP structural analysis program or ETABS or anything, StatPro. All these softwares will be running on two subjects. The first one is your finite element method. Okay, the first one is your finite element method, and the second one is your structural dynamics. Okay, the first one is your finite element method and the second one will be your structural dynamics. In the finite element analysis, element analysis or the finite element method, what are the different things which we do is a element will be meshed into many smaller elements, and the analysis will be done. This type of analysis is called finite element analysis. Like it will be a whole beam will be comprised, meshed and made into individual elements, and each element will be analyzed. This process is called as this is the background work which our software does, is called finite element analysis. All the modeling softwares, all the modeling and analysis softwares such as our StatPro, ETABS and SAP are based upon this finite element method. Okay, and the next part is our structural dynamics. In this structural dynamics we will be learning regarding, and also we have one other subject which will give the technical knowledge of our analysis, such as called, the subject is called ERDB, earthquake resistant design of buildings. In this we will be learning all the code parameters from IS 1893. IS 1893 we will be learning all the static equivalent lateral force method, or else we'll be learning the time history method, or else we will be learning the response spectrum and pushover analysis. From this, the basic technical knowledge we will be getting from this codes like IS 1893. The revised version is 2016. Okay, hello, am I audible now, sir?
You're audible, Arun. Yeah, that's what.
Yeah.
You can keep your mic very close. That's
Okay, sorry for the inconvenience, sir.
Yeah,
I'm just continuing. So the subjects are structural dynamics, and the first one is our finite element method, and the next one is our structural dynamics, and the third one is your ERDB, earthquake resistant design of buildings. These three subjects comes into role like whenever we are designing a residential building or any high-rise building, we'll be using these structures. Okay guys, these are complete academic knowledge which you require for coming into the construction field and be starting to work as a structural engineer. Now this is the basic things, basic fundamental things or the foundation things which you require in order to come into the construction field or the design field and start your career. Now let us go to our software and let us see how all these things will be will be represented in our software. Okay, now I'm just sharing my screen. So these are the different softwares which I deal with. Sir, is my screen visible, sir? Hello.
Yeah, Arun, your screen is visible. Yeah.
Okay, this is the start screen of your SAP. I'll be giving you a brief introduction to SAP. SAP stands for Structural Analysis Program. This is a software which is given by this which is provided by the company CSI, Computers and Structures Incorporation. Generally, we can do any type of analysis in our SAP. The difference between in this CSI, like Computers and Structures Incorporation, also provide different types of software such as our ETAPS, Perform 3D, and many other 3D structural softwares, 3D analysis and modeling structural softwares. The basic difference between your SAP 2000 and ETAPS is that ETAPS is completely based for buildings, like the abbreviation for your ETAPS is Essential Three-Dimensional Analysis of Buildings and Systems. Analysis of building systems. It will be completely based for your buildings only. Whereas in your SAP 2000, you can analyze buildings. You can also analyze different types of structures such as water tanks, solids, shells, staircases, and different types of elements in using your SAP 2000. So this is the extension file for your SAP 2000 is .sdb. The extension file for your SAP is .sdb, and in this is the start screen of your SAP 2000. Whenever you open this SAP 2000, you will be only highlighted with three options. These three options will be highlighted, and all the other options won't be highlighted. You can, in order to open a new file or create a new model, you can click on this file, and in order to create a new file, click on this new file. And if you want to open a new file, just click on this open a new file, and all the recent documents which you have accessed will be displayed at the bottom in your file. Okay, all the recent documents will be displayed at the bottom in your file. Now I'm just showing you how to set up a file. Click on the new model, and then you will be displayed with a dialog box asking you to set the units of the model. Basically the units will be kilonewton and meter, and then you will be displayed with different types of templates. In this, the first template, I'll be explaining you all these templates now. In this, the first template is your blank template. Whenever you select this template, when you open the SAP file, the template will be blank and there won't be any grid lines in the template. So in this template is used whenever you are importing any AutoCAD file, or whenever you are importing any files from the other softwares, this blank template is used. Okay,
First of all, this one is your units. You have to set the units, and then you have to click on this. You have to select the template which you want to work in. The first one is the blank template. This blank template is used to import some other file formats to your SAP 2000 and start working on that type of files. This template can be used to import AutoCAD centerline diagrams, and in order to start drawing from the AutoCAD centerline diagrams, you can use this blank template. And the next one, the grid only template. The grid only template will start whenever you use this template. You can set the center line, you can set the center line diagrams, you can specify the distance between the grids, and you can start drawing from this grid only. Like you can specify the grid to grid distance. Whenever you're drawing, there are grids in X direction, Y direction, and stories. You can specify the length and the number of grids you require, and you can start your modeling from this grid only. And the next one is your beam. If you want to analyze a beam, you can use this beam template, and then you will be having 2D truss, 3D truss. The main difference between 2D truss and frames is whenever you use these trusses, it will be only having in plane forces. Like it will be only having the tension and compression in the member. It won't be experiencing any bending moments or shear deflection. It will be only having the in plane forces whenever you're using this 2D and 3D trusses. Okay, in order to draw a 2D truss, you can use this in order to draw and analyze a 2D truss, you can use this 2D truss. For 3D truss, this one is used to draw high tension towers, high voltage lines, and telephone towers. You can use this 3D truss, and also you can use this to draw industrial sheds or the function halls which we see daily in our daily life. You can analyze those types of function halls, and also different types of industrial and commercial buildings with steel structures. You can use this 3D truss and 2D truss, and you can also use them as you can also do them in the 3D frames. The main difference between frames and trusses is the in-plane forces. The in-plane forces will be acting in your 3D truss. Only the in-plane forces will be acting in the 3D or 2D truss, and in 2D frames, the in-plane forces and all the other types of forces will be acting in your 2D frames and 3D frames. And coming to the next one, 2D frames and 3D frames. These are the templates which we generally use. This 3D frame is the template which we generally use for residential and commercial buildings. And the next one, in order to model and analyze any type of walls, you can use this. And flat slabs, I think you guys are familiar with the flat slabs. This slabs doesn't contain any beams. This only contains columns, slabs, and slab drops. For creating those types of models, you can use these flat slabs. And the next one is the shells. In order to analyze domes or shells or bunkers, silos, those kind of structures can be modeled using this type of template. And then in order to analyze the staircases, you can also analyze this staircases in the 3D frames. This staircases is completely separate to the 3D frames. In the 3D frames also, we will be providing a staircase, but if you want to do the deeper analysis, like in 3D frames, the moments and bending moments and shear forces will be only calculated, but in the 3D in this staircase, the contour meshing or the plate meshing of the elements will be done. Like the staircases will be meshed into finer objects, and it will display the contour stress diagrams, and at which part the more stress is experienced in the staircases, it will be displayed. And the next one is our storage structures. In this storage structures, you can analyze structures such as our in-type water tanks. Whenever we are traveling, we will be seeing in the township there will be water tanks, and also in the metropolitan regions we will be seeing this type of structures as water tanks. In order to analyze that kind of structures, we will be using this storage structures. Okay, and the next one is underground structures. This one is used to analyze the underground bunkers, or else whenever there is a petrol bunk, there will be an underground structure in order to store the fuel, like it might be diesel or it might be petrol. For those type of underground concrete structures, you can use this template. And then we'll be having the solid models. These solid models are used to analyze for chimneys, and whenever we have this larger dimension chimneys, we can use this solid models. And in order to analyze the pipes and plates, we'll be using this template. Okay, these are the different templates which are available in your SAP 2000. This complete different types of templates, in unlike ETABS or unlike any other software, this SAP 2000 will provide you different type of templates, like vast range of elements, vast range of structural elements or structural models you can analyze using this different types of templates. Okay, in this FDP, the main objective of this FDP is your residential and commercial buildings, analyzing residential and commercial buildings. And for that, we will be using only the 3D frames 3D frames template. Okay, for that we will be using the 3D frames template. In this, after clicking on the new model, after setting the units, and click on this 3D frames template. Okay, in this 3D frame, yes sir.
Yeah, a small clarification. I mean, this video is recording in your screen, right? It's in a recording mode already.
Yes sir, it is recording.
Yeah. Okay, then fine.
Okay. Sir, should I need to save the recording at the ending, or you guys will be doing
no,
this?
no need. I'm doing recording. It will record automatically. So what I'm saying is, record. That's it. Okay.
Yeah. Okay. Okay. Yes, sir. Okay. Let's continue with our FDP, our session. In the 3D frames, you will be displayed with 4 options. One is open frame building. This is an open frame building without consisting of any slabs. And the next one, perimeter frame building. Only the perimeter frames will be available. The internal beams and columns will be disappeared. Beam slab building, it will be comprised of beams and slabs, like it will be comprised of columns at the perimeters and the columns at the interiors, and it will be also consisting of slabs. And the last one, flat plate building, only the plates and the columns will be displayed. In this, in order to start our modeling, I'll be going with beam slab building. And also you can use this open frame building. In this also, after creating the model, you can create the slabs and you can draw the slabs. Generally, I'll be going to the beam slab building, as the slabs will be created by default. These are the different types of 3D frames. These are the 4 different types of 3D frames. The first one is the open frame building, only consists of frames and only consists of columns and beams. And the next one is your perimeter frame building. The difference between open frame building and perimeter frame building is, in the open frame building, you will be consisting columns in the internal parts also. In the internal also, the columns will be consisting. And in the perimeter frame building, only the perimeter of the building, the columns and beams will be created by default. And in the beam slab building, you will be also having slab along with the columns and beams. And in the last one, the flat plate building, you will be only having the plates and then the columns. Now I'm going to beam slab building. After creating this, you will be asked for to give the number of stories, number of bays in X direction, number of bays in Y direction. A bay is nothing but the empty space between 2 columns. The empty space between 2 columns, or the space between 2 columns, is called as bay. If you give 5 bays, 6 columns will be created. Like if you give n number of bays, n plus 1 number of columns in that direction will be created. Now I'm just giving 3 bays in the X direction, and I'm giving 3 bays in the Y direction. Okay, and then you'll be having this bay width. This the first one is the story, number of stories. I'm just changing this story height is the vertical distance. This one is the vertical distance. The story height is the vertical distance, and the number of stories is number of stories, how many replications of the stories you want. Now I'm just changing this to like 5-story structure. A 5-story structure with the three number of base in x direction is 3, and number of base in y direction is 3, and then the bay width in the x direction, let us assume the bay width as the bay width is nothing but the distance between one column to the other column. So the bay width will be let us assume 3.5 meters, 3.5 meters, and the bay width in the y direction, let us assume 4.5 meters. And these are the divisions are nothing but the distance, like how many divisions of the bay, how many divisions those are uh, divided into. These are the divisions. Uh, just put this to default, and this all these values are used whenever you are doing any geometrically symmetrical structure. Whenever you are doing this, you are entering this values, you'll the grid or the center line will be created in a way, in a geometrically symmetrical, which is uniform in each direction. Like this will be uniform spacings. If you want to create a grid line, if you want to create a frame with uneven spacing, you have to use this option called use custom grid spacing and locate origin. Use custom grid, you have to tick this option, and this will be turned off, and in this you will be having edit grid option. When you click on this box, this options will be turned off, and you will be having this edit grid option. Let me put this, I'll be explaining the slabs when we when we start modeling. I'm just moving this to open building frame. These are the same options. These are the same options. When you click on this, just click on this edit grid, and you will be displayed with define grid system data dialog box. Define grid system data dialog box. In this, you will be having the different ordinates. You can be the first grid line. This is the center line diagram. If you are familiar with the center line diagrams and the plotting, you will be understanding this one. I'll be explaining this once again. The first one is x data, x grid line data. In the x grid line, there are 4 grid lines. First grid line, this is the second grid line, this is the third grid line, and the fourth one. These are represented like the axis will be somewhere in the center, and these are represented with the help of the ordinates from the axis. Like in the x, it is -9 from the x. This a grid line is -9 meters distance from the x, and the b grid line is at the distance of -3 units, and then the c grid line is at the distance of +3 units from the axis, and the 9 grid line is at the distance of 9 units. D grid line is at the distance of 9 units from the axis. This is with reference to the ordinates. These grid lines are placed. Now, if you want to change this, if you want to just give the spacing between 2 columns or 2 grid lines, you can change this from ordinates to spacing. Previously, it was ordinates, and the next one it is spacing. So now, if you see over here, if in the ordinates, the value of the ordinate is given over here. The value of the x ordinate is given over here. Now, if you change to the spacing between A and B, the spacing between A and B is 6 units, is 6 meters. Now, the next one, the B ordinate, the spacing between B and C is 6 units. Now, again, the C ordinate, the spacing between C and D is 6 units. And again, if you go for the D, it is given as 0. Why? Because after D, there is no grid line. So whenever you go for the spacing, the last grid line, grid ID won't be having any spacing. It will be 0. Okay. Now I am just changing the spacing. The first one, I need it as 3 meters. I'm changing it to 3 meters. And the second one, I need it as 4 meters. Now, whenever you change the spacing over here, immediately the figure over here changes. Like the distance between the grid lines will be changed. Okay. The first one is 3 meters, And the next one, let us change this to 5 meters. Now the spacing will be changed. This will be, the C grid line will be moving a little bit closer. Just observe over here. And then after that, I'm changing the spacing in between this one. I'm giving it as some, again, I'm changing it to 4 units. And now, if you want to add more grid lines, like if you want to add more center lines, or if you want to add more number of bays in this X direction, just click on this add. If you click on this add, new grid lines will be created. If you want to delete the existing grid line, select the option and just click on the delete option, and that grid line will be deleted. And in this one, I'm just changing this one, as this both are 0, these are overlapped over here. D and E are 0 now, so these are overlapped over here. In order to change that, I'm giving the distance between D and E as some 3.5 meters. And okay, now the distance between D and E is changed to 3.5 meters. Okay, this is how you will be changing, you will be adding and changing the distances between the grid lines. And the next one, in the same process in the Y direction. Same process in the Y direction. Now I'm just adding one more grid line in the Y direction, and each one I need a uniform spacing of 4 meters. So I'm just changing this to 4, and again I'm changing this to 4. Okay, so these are the spacings in the Y direction. These are the uniform spacings in the Y direction. The last one is left to 0, as there is no grid line after 4. And the next one, at the bottom, you will be displayed with the Z grid data. This is nothing but your story data. This one is in the X and Y direction. This one is the story data. And if you want to increase another story, and click on the add option and give it a name as Z4 or anything which you prefer. Just change the previous one to the story head. Generally, our residential buildings are having a floor height of 10 feet, which is equal to around 3.23 meters. So we are round figuring it to 3, or else you can, if you want to be precise, you can go for 3.23. Generally, I'm now giving this as 3 meters, and just click on this. Okay, first what you have to do is in this 3D frames template, select the open frame building, use custom grid spacing data, and then click on the edit. You will be displayed with define grid system data. In this grid system data, you can provide different grids. You can provide n number of grids just by clicking on this add. These grids are nothing but the lines where you place the columns, or whenever you're modeling, you will be modeling on the basis of the intersecting points of these grids. This one is the A grid. This one is the X direction grids. This one is the spacing of the grids. In order to create a new one, click on the add and give the spacing, and the last one should be left to 0. This one is when you provide this as spacing, and if you click on the ordinate, you have to provide the ordinates with respect to the origin. The origin will be somewhere over here in the middle of the model. You have to create on the with respect to the origin in the X direction and in the Y direction. I prefer to use spacing as it is more convenient. I prefer to use this spacing. So you have to give the spacing between the grids. You have to give the base spacing. And the next one in the Y direction, also you repeat the same. I am giving this as uniform spacing. And the next one is our Z grid data. Z grid data is nothing but your story heights. Your story heights. I have given 4 stories, which each one will be 3 meters in height. And after that, just click on OK. Just click on OK, and the grid data will be saved. And in this, you can provide default beams. By default, there will be some beams. You can provide it over here, or else you can also model them after opening your working area, or after opening your model. Now we are just setting up the template, guys. Remember, we are just setting up the template. In the edit grid data, edit everything. Give the grid data and click grid data and the story data and click OK. And after that, you can give the section properties over here, or else also you can do them after opening the project. Now I'm just opening the project, and this one is a restraint option. Restraints are nothing but the support conditions. Whenever you model a structure, there should be support conditions. Universally, all the support conditions for an existing building are fixed supports, like the foundations are of fixed supports, except whenever we are using this floor isolators or in for our research purposes, or at some buildings we will be providing floor isolators. Not much in our India. We will be providing this floor isolators. For that, the restraints will be changed. For all the other buildings, all the foundations are of fixed supports. These support conditions are nothing but called as restraints in your SAP 2000 or any of the modeling softwares. Just click on OK, and the model will be generated with the values which you have given. The model will be generated with the values which you have given previously. And this one is your start screen of SAP 2000. This is the start screen of your SAP 2000. I'll be explaining the user interface now. This is the main menu. The upper one is the main menu. This one is the top one is the title bar, and after that this is your main menu. These are the tool menu. These are the tool menu. These are all the different shortcuts which are placed across your working space. You can rearrange these shortcuts just by placing the mouse over here and just dragging them. You can rearrange this icons. You can rearrange this shortcuts. These are the different tools which we use for modeling and analysis purposes. These are the different tools. Now let us go through this each of the menu option. The first one is the file. As you know, in the file you'll be having options for creating a new model, opening an existing model, save as, importing and exporting from other softwares, and or accessing the files which you have recently opened. This one is the file option. And the next one is the edit option. In the edit option, you will be having options for cut, copy, paste, delete, in order to cut any of the object, or copy any of the object, delete, or replicate. Replicate is nothing but copying the object. All these options will be in your edit menu. And after that, you will be having the view menu. This one is used to set the different views. In order to zoom in, zoom out, pan, or else in order to make the grid lines visible. Now if the grid lines are visible, right, the bottom, this gray area, or this center lines are called as the grid lines, which you have set up just before while you are setting up the template. These are called as the grid lines. In order to make them visible and invisible, you can use this grid line option. And the axis, as I have explained before, this axis will be somewhere in the center. Axis will be somewhere at the center. This is your axis. In order to make it appear and disappear, you can use this axis option. And then you will be having the define. From here, our structural part, or the modeling part, or our academics which we have learned will be useful. The first one is the material. As we have discussed previously, the materials, from strength of materials, we'll be getting all the, what do we say, all the properties of a material, such as its Young's modulus, its density, and whatever the different things, the material properties. You can set up the material properties over here. We'll be explaining this in the next classes also. I'm just briefing you now. See, this is the different material properties, such as density, weight per unit volume, modulus of elasticity, Poisson's ratio, coefficient of thermal expansion. You can also do thermal analysis in using this SAP 2000. You can also check the temperature stresses and everything in this SAP 2000. And if you switch to advanced properties, it will be showing some properties such as the isotropic, uniaxial. Like this one is the loading options. You will be having few other options like nonlinear material data, material damping properties, and thermal properties. This nonlinear material data and material damping properties are very much important when you are doing this nonlinear analysis, such as time history analysis and pushover analysis. These are static nonlinear and dynamic nonlinear analysis. In order to incorporate the nonlinear properties to your structure, you will be using this nonlinear material data and material damping properties. You will be changing these parameters to incorporate those properties into your structure. This one is the material properties, and then you will be having section properties in order to define the section, the different size and shape of a section, like it is a circular section or else a circular column or a rectangular column, or steel sections like I section, channel section, T sections. Any type of sections you can set up the dimensions over here. And also there is an option called section designer. This one is called section design. These are all the basic general sections which we generally create in our while modeling. There is another option called as section designer. This section designer is used to create an existing designed section, like with all the reinforcement and all those things. We can use this section designer to create such type of sections. Like this one is very useful for your M.Tech thesis or research purposes. This section designer is very useful. You just have to this is the stress strain curve of your model. You have to set the bar sizes. You have to enter few parameters over here, and then you have to provide the reinforcement to the structure and click OK. So in this way, you can create an existing structure. You have, whenever you take an existing structure and it already is designed, it has been designed already, like an existing building. Its detail, its structural details, you have to take the dimensions. You have to take the diameters of reinforcement which is provided inside the structure, inside the beam or column from the structural drawings, and through that you can create a similar element in your SAP-2000, and you can check the moment curvature. This moment curvature is very important. 1 minute, guys. Okay, this one is the moment curvature. Whenever we are dealing with the mild steel moment curvature, we will be getting few points, right? Like the yield point, breaking point, ultimate point. You guys remember these things, right? All these things will be in this moment curvature. These are the different points. This one is the final collapse point. This one is the yield point. This one is the ultimate point, and all these points will be represented in your moment curvature. Based on this moment curvature plot, based on this moment curvature plot, you will be getting the yield moment and the maximum moment which is occurring in your section, which the section can retrain. All these values you have to note down in order, whenever you are this curvature and moment values, you have to note down whenever you are doing this nonlinear type of analysis. This nonlinear type of analysis using this section designer. This one is a section designer. You have to set all this up whenever you're doing pushover analysis or time history analysis. This section designer is very useful. And the next one, in the view, in this menu, you will be having options for function in order to create a time history function, in order to create load cases or load patterns or loadings, or in order to create load combinations. You will be having all the options in this define. And the next one is the draw command. First we have set up our model, like we have created the grid lines and story heights, and then we have created the materials in sections, and then we will be starting to draw the structure. We will be starting to model the structure, and after that assigning the loads. In this assign, we'll be having the different options to assign the loads, and in this select, we'll be having different options to select different materials or different elements in the model which we have created. Like if you want to select only the beams, you can select the based on the properties, like selecting the parallel lines. All the parallel lines have been selected, or else you can also select from the properties. Like I have created one property. If you want to select the elements with that property, you can select that option. Now F1. Okay, all these elements are of F section 1, so all the properties have been selected. This is one of the method of selection, and also you'll be having different types of selection methods. In the assign, you will be having the joint loadings and different types of assignments, such as in order to assign the restraints, the fixed supports to the restraints, you can go for joints, frame assignment, and hinges assignment. Different types of assignments in the assign, like loadings and the frame assignments. Next one is analyze. In this analyze, you will be analyzing the structure. You will be running the model for different load cases and different types of analysis. In the display, after the analysis, all the outputs will be displayed using this menu, this display menu. And after analysis, we will be going for the concrete design or the frame design. This will be in this design menu. And these options are nothing but the extension for your software. Like if in order to change any of the interface, or change any of the settings, or change any of the colors of your materials, you can use these options. And these tools are used, this two options are used, this help is used for accessing the manual of SAP 2000. You can access the manual, you can access the web for help. In this tool, you can access like you can provide different types of plugins to your software, and you can use the software. This is completely about your main menu. And then these are the different shortcuts which are inside the main menu, like whatever the icons which are represented over here, those are the icons which are represented on the just below of your main menu. And then this one is your working screen. This is the active window, the place where the blue one is highlighted. This one is the active window, and this one is the inactive window. Whenever you are drawing in this active window, it will be highlighted with the blue color. And whenever you made any changes in the active window, if the view is 3D, it will be immediately displayed in the 3D view. Okay guys, and the next one, you can add in more windows just by, now if I close this window, this one will be becoming the active window. And if I want to add one more window, just click on this drop down option and click on add new window. Okay, you can change the views from these four options. The first one is a 3D view, which now it is represented. This one is a 3D view. And the next one is your XY plane. When you see the axis over here, you will be represented with the XY plane. If you click the XY plane, it will be changed to XY. The view will be changed to XY plane. And you can change the story which you are working in. Now it is in the 9. Whenever you are selecting the 9, it is at the top level. Like whenever you are highlighting something over here, a blue plane will be represented in the inactive window. In the inactive window, a blue plane will be represented over here. Just observe it over here. If you see on the left side, there is a blue plane represented. Now if you click this move down in list, it will be moving to the second round. Now the XY plane, it is at the level of Z6. Z is equal to 6 meters. Now it is moved to the second level. Now again it is moved to the first level, and again now it will be moving to the base level. And again we can go to exit. In the exit view, this one is the plane, this one is the exit plane. Similarly, again if you click on these arrows, you can move to different frames. Like in the XY plane, you can exit plane, you can move into the different frames. And similarly in the YZ plane, using these arrows, now the outermost perimeter frame is displayed. If you see, there will be a plane highlighted over there, and by clicking these options, you can move this to any other frames. And then at the bottom right, guys, at the very bottom right, you will be displayed with the default units which you have set at the beginning. You can change the units from here, like kilonewton meter and kilonewton meter centigrade. Now if you want to change to kilonewton centigrade, just click on the other option. Now whenever you click on this kilonewton and centigrade, this will be displayed to -600. Like 6 meters is -600 mm, 6000 mm, so it will be changed to the appropriate units which you have set, which you have selected. Okay, so I'll be showing you now. This is about all about your user interface, the main menu. What are the different tools which you have, or the different working tools, or these are the different shortcuts which are in the menu. These are the different shortcuts. You can access them, you can move them and place them anywhere. This is the working, this is the active window, and this is the inactive window. Now I'll be just showing you one of the project which I have did. This is for you. Okay, this is a project on which I have performed the static nonlinear analysis, which is called pushover analysis. So when you click on this display, you'll be in this display, you'll be having all the outputs. In this, if you click on this static pushover curve, you will be displayed with the displacement by base reaction. The roof displacement by the base reaction. This is the static pushover curve after the pushover analysis, static nonlinear analysis. This is the curve. And in the display, if you click on this, what is it? Show deformed shapes. These are the different hinge formations for your model. Like whenever you do this static nonlinear analysis, it will, after the analysis, the hinge formations, like the hinges are nothing but the yield points. These are displayed with different colors. Each color represent different damage stage. The different damage states are immediate occupancy, collapse, life safety, and collapse prevention. I'll be explaining them in the coming classes, in the next whenever we are dealing with this pushover curves. These are the different hinge formations. And there is an option called animation, start animation. It will show the moment of the building whenever you are doing this pushover analysis or any type of analysis. It will be display the moment. It will with the animation, like how the building is reacting to the load which you have applied. It will be showing with the animation. And in this, when you see over here, guys, there are few icons over here, the same icons, like show forces. This will be displayed in the shortcuts. In this, if you click on this option, the bending moment in the major direction, third direction, 3 direction, the and the axial forces, all this will be displayed for the load case which you have selected over here. Like for the dead, this one is for the dead case. If you want it for any other load case, like this one is a dead combination, it will be changed. You can select any of the load case, and you can see what are the bending moments and what are the shear forces which are represented. If you click on this show values, it will display the values. We'll be dealing with this in the coming classes. This is just for your references. This is one of the model. And now this one is the shear walls project. Whenever you provide the shear walls, it will be like this, something like this. And in this, I have done the time history analysis to display the plot functions. In this, we will be displaying the plot functions. Um, This one is the time history function. Whenever you are giving a ground motion to the structure will be moved, and the displacement, the top displacement or the joint displacement will be noted according to the earthquake ground motion acceleration file. This will be formed. From this you will be getting the maximum displacement at each time period, at each time second. The Koina earthquake function I have used for this building. This one is the ground motion file. When you apply this ground motion file, the model will be subjected to acceleration, ground acceleration or ground movement, and it will generate this type of outputs. Like for the ground motion which you have given, this is the output which the model generates. Okay, these are the different type of analysis which you can perform, like pushover analysis and time history analysis using this SAP-2000. Okay guys, so that's it for this session. In the next session, my colleague K. Tejaswini will be taking the session. She will be dealing from the starting, like how to model a structure, how to set up a structure, and all those things will be dealt with her. So that's it for today's session. I'm now handing over the meeting to Sir VAMSI KRISHNA, sir. Sir, how to hand over this meeting, sir? Hello. Hello. Guys, if you have any queries or any doubts regarding the session or the meeting, just post it in the chat box. I'll be answering you for now.
Have
Are
you
there
stopped
any?
the screen sharing?
Yes, sir. I have stopped the screen sharing.
Okay. So now you are allowing them to ask for doubts, right?
Yes, sir.
Those who want to put any question, they can unmute and they can ask a question, right?
Yes, sir. They can unmute and ask the question, or else they can put them in the chat box also.
Yeah, chat box.
Yeah, Arvind this side. Am I audible?
Yes, sir. When you are audible.
Arvind
Hello.
Prakash Naik, sir, you are audible, so you can ask your question.
Hello. Yeah, Arvind this side. Am I audible?
Yes, you are audible, Arvind.
Just anyone confirm? Actually, I am getting this. My voice little bit hazy.
No,
Hello?
your voice is audible, Prakash. You can ask question.
Yeah. Thanks for confirmation. Sorry for inconvenience. Actually, see, I passed out in way back 2007, so I have been long disconnected with this theory part. So better if we'll be getting any handouts so that we can quickly review the basic of this structural analysis part. So that will be very helpful for us to connect to the subject and for better appreciation, if it is possible. Thanks.
Okay, Arvind, the thing is that we are providing you the recorded file. We are giving you the recorded file directly. That's why I have started to explain the basic structural engineering part. Like I have dealt with all the subjects in the beginning, right? In the beginning, I have explained all the SM, SA, RCC, whatever the things which we are doing. So how they are impacting in our software. This recorded section will be handed over to you. This recorded section will be handed over to you, Arvind.
So as Prakash is asking for structural analysis material, in the sense like what he already studied in his structural analysis subject. So if you want any kind of notes related to SA Prakash, you can ping me personally, where I'm gonna show you lecture notes to you, where you can brush up your fundamentals. Okay, Prakash?
Yeah, sure, sir. Thank you. Thank you so much.
Yeah. So because yeah,
Thanks a lot.
as
But it
this
is
is
very
completely
wonderful.
FTP on SAP, right? Yeah, that's all. As this is completely software training program, here we can't share those details. So you can personally, you can just text us. So by this, we will share you essay notes. So whatever you require, and by that you can brush up your.
Yeah, thanks you. But I'm finding this wonderful. Actually, for me, this is a very good session. Thank you. Thanks a lot for you guys to making this event. Thanks.
Thank you. Thank you so much, guys.
Thank you,
Any
Arvind.
others? Others, they can put your question over to Arun. Ram? Anyone? So because as per schedule today is just for introduction of SAP 2000. So where I think Arun gave glance about toolbox and the command box of SAP 2000.
Yes, sir.
Yeah, that's it. That's it, right, Arun? Yeah.
Yes, sir. Yes, sir.
Okay. So in that point of view, like if you have any doubts, you can put it for it.
Yes. Yes. Who is this? So, is there anything which you guys wanted to get clarified regarding the FDB, like regarding the topics which we are going to explain? If you want anything, if there is anything, any queries regarding those topics, you can also put them in the chat box, or you can ask me now.
Hello, sir. This is Santosh.
Yes, sir.
Uh, hello,
Happen, sir.
sir. What is the difference between mainly that StatPro and SAP? Is it need to learn StatPro also for the learning of SAP?
It is not required to learn StatPro to learn SAP 2000. This two softwares are different softwares, like the same process, the analysis or the loadings analysis or the thing which you do in the both softwares is same, but these are provided with two different companies. The StatPro is provided with Bentley company, and this SAP 2000 is provided with CSI. When you compare these two softwares, the outputs from these softwares are same, but the method how you use these softwares, like the interface of StatPro is very old. The SAP 2000, it will provide more interface and more type of analysis. In basic version of SAP 2000, you can do the pushover analysis, time history analysis, and everything. But in StatPro, in the basic version, you cannot do that pushover and time history kind of analysis. The higher analysis you cannot do in
Yeah. Okay. Thank you, sir.
both softwares are different. It's all different actually. But the output is same. But the type of things which we do internally in the software are different. Good afternoon, sir.
Arun, there is a question. Yeah, can SAP can be used for design of foundation? Yes.
No, Milind Gupta, no. SAP cannot be used for design of foundation. There are a few other softwares which are provided with CSI, like Computers and Structures Corporation. They provide few other softwares such as what do you say, RFM and Stat Foundation. You can use Stat Foundation. You can use this RFM for foundation designs. You can use a few other softwares for design of foundation. You cannot do the foundation design in SAP 2000.
Muhammad Ali, actually, we already shared software links to your mails. You can just go through your mail and you can activate your software. And there is a clear procedure was given how to install the software also. Okay, so that you can follow up. Muhammad Ali. Mohammed Ahmad. Dear guys, actually just here I would like to share the program schedule once again. So as today we started with the inaugural session and introduction to SAP 2000. So I hope you are all done with the introduction part. And tomorrow we are going to start with the modeling, so which includes the setting up grids, defining materials, and defining sessions. Okay, and the day after tomorrow on 16th December, so you're going to learn about how to do loadings like gravity loads, lateral loads, you know, so which deals with all kind of gravity and lateral loads, which followed with analysis and results. And next on 17th it will be a concrete design with the time history analysis, so by using unscaled ground motions and scaled ground motions, right? And on 18th it will be like a pushover analysis, so using auto hinges, section designer, and user defined hinges. Okay, on the same day there will be one more thing, which is development of a practical model and analysis. Okay, so which ends up with the certificate distribution after getting your feedback on the program, right? So this is the program schedule what we planned for this, right?
Yes.
You can
There
find
is
the
a
same in
question.
your, yeah.
There is a question. Sorry, sir. Sorry for interrupting.
It's okay, it's okay. Yeah, you can continue, Apurva.
There is a question from M. Apurva Yogya. Can you please explain difference between finite element analysis and structural dynamic method? Actually, finite element analysis is a method, but structural dynamic method is not a method. It is a subject. It is a concept. It is a concept which involve the different
No,
called in your
people are asking those.
in structural engineering. Finite element analysis is a type of method, like just like our Canis method or a moment distribution method. This is a method. Finite element analysis is a method of solving the problem, solving the forces, resultants, stresses, or bending moments, or everything. There is a method that is called finite element analysis. Whereas our structural dynamic, it is a complete subject. It is a complete subject. So these two are completely different. Finite element analysis is different and structural dynamic is different. We use the finite element analysis method to do the structural dynamics and the concepts of structural dynamics for solving the problem. We use the finite element analysis problem method and the concepts of structural dynamics in order to solve the problem. So these two are different types of subjects. Like the first one is a problem and the second one is a concept.
Guys, a small information. So those who have registered and got the links for the sessions, so please don't share these links to anyone, because we are taking attendance every day. So those who are not registered and been in this session, so we are going to block them, right? So just now we found one person and we blocked him. So requesting again, so please don't share these links to anyone. Okay. Thank you. Arun, tomorrow what you're going to present and who is going to present, you can share that to participants.
Yes, sir. Yes, sir. Tomorrow, my colleague K. Tejashwini, she is also a structural engineer. She is working along with me. She'll be going to present the as per schedule. She's going to present the first part, which is modeling, loadings, and analysis part. In the next class, in the next FDB section, you will be completing all the static linear analysis, like the general analysis, until the concrete design. And also the concrete design you will be finishing in the next FDB section.
So I think Tejasvi is also there in the session. Tejasvi, you can say hi to participants. You can unmute and you can say hi. Tejashwini. Tejashwini.
She's offline, sir. She's
Are you there?
offline. She's offline.
She's offline. Huh? Okay.
Yes, yes, she's
So if
offline.
you can contact her, you can contact her, and I think she can just give a brief about her.
Yes,
So by that we
yes,
can start the session tomorrow immediately. You know,
yes, sir,
once.
definitely. Definitely, sir.
Guys, in the chat box, you can give your feedback. How was the first day session? So I request participants, you can share your feedback. How was the first day session? Please, I want everyone to be a part of this feedback. You can just view the feedback of the today's session, and the overall feedback will be on end of the day, right? That is on 5th day. But just for glance, just we need how we are running program and how we are clarifying your doubts and all. Okay, you can share your, view about this program on the first day. Sir, his title you got as well. Sir, Arun, Tejas, you joined her?
Yes, sir. She just joined, sir.
Okay.
Sir, wait, sir.
Tejasvi, you can introduce yourself.
So good afternoon all. Good afternoon, sir.
Yeah.
I can't on my video. There's some technical problem. So I want to
Okay, no
introduce
issue.
myself.
Your audio is fine.
Okay. My name is Tejaswini, and I'm a structural designer from URK Planners. And tomorrow onwards, I'm here. I'm here to take the SAP software, in which we are going to model a building, and we are going to do a static analysis and nonlinear analysis in which the output of this program will be you can able to use a SAP software to design and analyze a building by using static and dynamic analysis. This is my introduction.
Right, fine, Tejasvi. Arun, anything you want to say?
So that's it, sir. In the next section, Tejaswini will be dealing with the modeling and analysis part, and the static part, and the concrete design. So
this is the introduction part. I hope everyone have understood the basics of our structural engineering, like what are the different subjects and how they are impacting our SAP software, and what is the user interface and how to set up the grids. I hope everyone have understood. And if anyone have any doubts or any queries, just ping me to my number or just I'll be.
Yeah, and this session was recorded, and we'll be sharing this link to your mails, respective mails. Okay. See, we are going to correspond each and everything to your mails, guys. So because we created WhatsApp group, but no one is responding in that. So we are going to share this link, and whatever further correspondence, everything will be shared to your mails. Okay. So please, go through your mails every day. So, and tomorrow's session also will be updated today evening itself. Okay. And the link in the book. That's it. Arun,
Yes.
yeah, some message. Yeah, thanks. Okay then, guys. So see you tomorrow, and I request all of you, please be in online 10 minutes before the session starts. Okay, so by that everyone can be, be in the session from exactly by 11. Okay. Yeah. That's it, Arun. Anything else?
Yes, sir. That's it, sir.
Okay
That's
then.
it, sir.
Yeah.
That's it for today's
So
session.
yeah, we are going to
We'll
close
be
the
meeting in
session.
the next session.
Sure. Yeah.
Thank you very much,
Thank you
guys.
so much, guys. Thank you all for all the participants.